Hello, my children, and welcome to a brand new chapter. In chapter 11, we will be looking at the topic of functions. So this first lesson to get us introduced into this topic is on the lesson of sequences. So a sequence is just a set of numbers that follow a pattern. So a couple of examples of some different types of number sequences can be the number sets of odd numbers and even numbers. Because if you look at the pattern and how the numbers change, they go up by 2 units every single time. So that's a pretty simple example of a very common sequence that we're all familiar with. Now, we're going to be learning 2 different types of sequences in this lesson. The first type of sequence we're going to learn is something called the arithmetic sequence. So the arithmetic sequence is just a pattern of numbers in which the next number is the result of adding a fixed number. So let's take this example that we have right here. We've got these 4 values, and then we got some blanks after it, so we're going to find some missing terms. Now, before we jump in and determine what those missing numbers are, let's answer some initial questions first. So the first question, what is the initial term? So that's just a fancy way of saying, well, what's the beginning number? Well, pretty straightforward here. Our beginning number in this set is the value of 3. And then the next number is, well, what is the common difference? Common difference is just the fancy way of saying, well, what is the fixed number that we are adding by? Well, if we go from the first term to the second term, that increases by a value of 4. And we can see that that pattern is consistent because it's the same fixed number every single time. So plus 4, and we see that it works and we get the same values up the line right there. So the common difference is 4. Now, just a little note for you guys. Sometimes the common difference can sometimes be either a positive or a negative number. So if you see a pattern of numbers where they're decreasing, sometimes the common difference may be a negative number. And we'll look at an example of that in just a moment. So now, let's find the next 3 terms now that we know what the common difference is. So if we answer these questions as follows, so 15 plus 4, that is going to give us 19. And then the next one, 19 plus 4, will give us 23. And then 23 plus 4 gives us 27. Let's try some quick check problems out. I would encourage you to pause the video right here and try these problems out on your own. For the directions, we're going to identify the initial term, the common difference, and the next 3 terms of each sequence. So take a moment to pause the video right here and try these problems out on your own. And then when you're done, you can play the video and see how your work compares with my answers. All right, now that you've worked out the problems, let's try number 1. So here's our sequence. Let's identify the initial term, which is our starting number here. So our initial term is 7. And our common difference, well, it looks like it's increasing by a value of 2. And one thing that we do need to keep in mind that in order for it to be truly an arithmetic sequence, it has to be the same fixed number that adds every single time. The fixed number cannot change. If it does change, then it's not truly arithmetic. But in this example, it is a constant term, so the common difference is positive 2. So now, if we fill this out, the next 3 terms would have to be 15, 17, and 19. Let's try number 2 out. So the initial term, as you guessed it, would be the first number here, 15. And if we take a look at the common difference, well, again, this sequence is increasing. So it looks like we would add by 6 every single time. So add 6 again, and then add 6 again. So that is consistent. So our common difference is positive 6. So let's figure out what the next values would be. So 33 plus 6 would give us, 39. All right, 39 plus 6 would give us 45. And then 45 plus 6 would give us 51. There you go. All right, last example. So our initial term, again, would be 24. So there it is. In our common difference, oh look, this sequence is decreasing. How much is it decreasing by? Well, it looks like it's decreasing by 4. So the common difference is we're adding a negative number to the pattern. So our common difference is negative 4. So the next 3 terms of this sequence, well, 12 plus negative 4 would give us 8. Then 8 plus negative 4 would give us 4. And then 4 plus negative 4 would give us 0. Now, could you keep going with this? Absolutely, you certainly can. So if you wanted to find, so this last term that we found here was the 7th term. So if I wanted to find the 8th term, then I would do 0 plus negative 4. And that would give me negative 4, then negative 8, and so on and so forth. The second type of sequence we will be looking at in this lesson will be called the geometric sequence. So the geometric sequence is a pattern of numbers in which the next number is the result of multiplying by a fixed number. So this example down below is a perfect example of that. Now, if we were to try to use the arithmetic rule, we see that it's not the same number that we're adding by every single time. But if you look carefully here, we see that there is a pattern. It looks like the numbers are doubling in value. Now, if you're uncertain about whether or not something is geometric as a sequence, there is actually a way to figure that out, and that's by finding something called the common ratio. All you would have to do is take the following term and divide it by the previous term. So for example, if I wanted to find the common ratio between the first and the second number, then I would do 6 divided by 3. Now if I do that, 6 divided by 3, guess what? That gives me 2. And that makes sense because look, if we go from the first term to the next term, it's times 2, then 6 times 2 would give us 12, and then 12 times 2 gives us 24. So we see that that rule is consistent. And then, of course, the initial term, we can't forget about that. We already know that the beginning term is 3. So now let's find the next 3 terms. So all we're going to do, because we know the common ratio is multiplying by a fixed number, in this case it's going to be 2. So 24 times 2 gives us, you guessed it, 48. And then 48 times 2 gives us 96. And then 96 times 2 gives us 192. A little tip I want to give you guys is that sometimes when you're determining what the common ratio of a geometric sequence might be, sometimes it may be a fraction and sometimes it may be a whole number, like in this example that we have off to the side. So make sure you pay close attention to whatever geometric sequences you're working with, because sometimes the common ratio could end up being a fraction. Let's try this next example out. So we're given the first 4 terms, and just like the first example, we're going to find the initial term, the common ratio, and then use that information to help us to find the next 3 terms of this pattern. So if you take a look at what number we're starting with, we see that the pattern is decreasing. Well, if we study carefully, it doesn't look like we can add a fixed negative number every time, because the negative number would change. So this must be a geometric sequence. So first of all, let's identify our initial term. So that's our starting number right here, which is 27. And then let's determine what our common ratio would be. So we're going to take the second term and divide it by the first term. So if we do 9 divided by 27, we get 9 27ths. Or, if you know your fractions, you can reduce that down to 1/3. So our common ratio is the fraction 1/3. So if we were to multiply by 1/3 continuously, 27 times 1/3 is 27 thirds, which is the same thing as 9. Then 9 times 1/3 is 9 thirds, which gives us 3. And then 3 times 1/3 gives us 3 thirds, which is 1. So if we continue that pattern, let's do that to find the next 3 terms. 1 times 1/3, well, that's easy. 1 times any number is just that number itself. So 1 times 1/3 would give us 1/3. And then 1/3 times 1/3, well, remember if you're multiplying fractions, you multiply straight across on the top and on the bottom. So 1/3 times 1/3 would give us 1/9. And then 1/9 times 1/3, well, 1 times 1 would give us 1. 9 times 3 would give us 27. Let's try some quick check problems out. What we're going to do for these next 3 problems, we're going to identify each sequence as arithmetic, geometric, or neither. Then find the next 3 terms of the sequence. You can pause the video right here and try these problems out on your own. And when you get done, play the video and compare your answers. All right, so let's look at number 1. Well, if we study this carefully, it looks like this one, because of the pattern, what we're working with, would be geometric. And the reason for that is because we're multiplying by a fixed number of 1/2 every single time. So we can go down the list here and see that that common ratio is consistent. So 1/2 times 1/2 would give us 1/4. Then the next term, 1/4 times 1/2 would be 1/8. And then 1/8 times 1/2 would give us 1/16. So let's try the next problem out, number 2. Well, it looks like it's an alternating number sequence. So we're going up 1, then back down 1, up 1, down 1, up 1, and so on. So we're technically not adding a fixed number every single time. And we're not multiplying by a fixed number every single time. So this one would actually be neither for this situation. Oh, and I forgot to mark up here. So number 1 was indeed a geometric sequence. But because we do recognize the pattern, we can still finish it out. So the next term would be 1, then 2, and then 1. So now let's look at the last problem down below. So it looks like we are adding a fixed number every single time. And it looks like we're adding a negative number. We're adding -20 every single time down the line right here. So let's figure out what the next 3 terms are. Oh, and again, since we're adding a fixed number, this is an example of, you guessed it, an arithmetic sequence. So 10 plus -20 would give us -10. Then -10 plus -20 would give us -30. And then -30 plus -20 would give us -50. Hope you found the first part of this lesson helpful. Let me know if you have any questions. Thank you.